So this is the Honors Chemistry lesson video for section 6.1. So we are going to start talking about the periodic table. So chemists use the properties of elements to sort them into groups. So the periodic table has this odd shape for a reason. It's based on the groups, the electron configuration, and things like that. And see, y'all, the more you learn about the periodic table, the more you'll realize that it's the best cheat sheet that you can ever get on a chemistry test. It's just you have to understand how it works. So that's what we're going to start learning. So Mendeleev is credited with creating the first useful periodic table. He arranged the elements in order of increasing atomic mass, and then he also put elements with similar properties in the same group. So he put his in order by increasing atomic mass and kept elements with the same groups, same properties grouped together. And so that ended up making a very useful periodic table. And so we'll talk about how. So when he finished, he actually left blanks in the periodic table if there was no element that fulfilled what he thought should go there. Well, since he arranged his periodic table based on properties, he actually then predicted properties about elements that had not even been discovered yet. Well, once the elements were discovered, his predictions were right. Okay, so it's one thing if I make a periodic table and predict some properties about stuff that hadn't been discovered, but then for his predictions to be right, that's what made everybody realize, like, oh, wait a minute, he must be on to something here. So he was predicting accurately properties about elements that had not even been discovered yet. So that brings us to our modern periodic table. So Mendeleev arranged his in order of increasing atomic mass. Well, eventually we determined that we could count the number of protons in the nucleus, and we came up with atomic number. So our modern periodic table is arranged by increasing atomic number. We still keep elements in the same group that have similar properties. Elements in the same period have a repeating set of properties. This is referred to as periodic law. Okay, so in a group or a column, they have similar properties. As you go across the rows or the periods, you see a repeating pattern of properties. So the periodic table can be broken up into metals, nonmetals, and metalloids. And so you can see them color-coded here. Your yellow are your nonmetals, your green are your metalloids, or sometimes they're called semi-metals, and then the purple are the metals. So if you look, there is a darker stair-step line that travels right here, and that splits the two sides. So all the elements that touch the stair-step except for aluminum are your metalloids. Your metals are on the left, middle, and bottom of the periodic table except for hydrogen, and your nonmetals are on the right of the periodic table except for hydrogen. Hydrogen has to ruin everything. Sometimes you'll see it written over here, just like on this periodic table. Because of the properties of hydrogen, it kind of belongs in both places. So let's talk about some of the characteristics of these things. So some of the properties of metals include that they tend to be good conductors, they are shiny, they are all solid at room temperature except for mercury, they are ductile, which means they can be pulled into wires like this, they are malleable, which means they can be hammered into sheets. So in a movie, when you watch like a blacksmith and they stick some metal in the fire and pull it out and start hammering it to make a sword, that can happen because metal is malleable. They tend to have low ionization energies. We'll talk more about ionization energy in section 6.3, but for now all you need to know is that's energy needed to remove an electron, which makes sense because metals don't have very many valence electrons, so it's easy to take them away to make them more stable. They tend to form positive ions. Metals are on the positive 1, positive 2. The transition metals all have positive charges. And then they tend to be oxidized, which again, we'll talk about oxidation and reduction more later. Oxidation is loss of electrons, which makes sense because they're positive, and it doesn't take much energy to remove them. And reduction means gain of electrons. So oxidation is loss, reduction is gain. So all three of these go together. If you'll remember they're positive, that means it's easy to remove an electron, so it's low ionization energy. And since they're positive, that means they tend to lose electrons or be oxidized. Most metal oxides are basic. Bases produce OH- ions or hydroxide ions in solution. So bases produce OH- when dissolved in water. And so here we have a metal oxide. It's a metal with oxygen, sodium oxide. And in water we get NaOH. And so there is your hydroxide. And same thing here, we have calcium oxide. That's a metal and oxygen. and in water it produces calcium hydroxide, which of course is a base. So once you learn about metals, nonmetals are practically the exact opposite. So nonmetals tend to be gases, whereas metals tend to be solids. Nonmetals tend to be poor conductors, except for carbon, whereas metals tend to be good conductors. Nonmetals tend to be brittle, which means if I hit them with a hammer, they will break. Like I can't change the shape. Whereas metals tend to be malleable and ductile. I can easily change the shape. Nonmetals tend to be dull, whereas metals tend to be shiny. And then here are the three that kind of go together. So they tend to have high electron affinity. So again, in section 6.3, I will talk about electron affinity, but it's the energy change that occurs when an atom gains an electron. All right, so it has a high electron affinity. So the energy change that occurs when an atom gains electrons, because they tend to gain electrons. They form the negative ions. So if you remember when we did our charges across the periodic table, on the right of the periodic table, that's how we have our -4, -3, -2, -1. And then because they form negative ions, they tend to be reduced. And so remember, oxidation is loss of electrons, reduction is gain. So since they tend to be negative, they tend to gain electrons. All right, so non-metal oxides tend to be acidic. So metal oxides tend to be basic, non-metal oxides tend to be acidic. So like I said, everything between metals and non-metals is pretty much just opposites. So if you learn one of them, then you know the others. So acids produce the H+ ion in a solution when dissolved in water, or sometimes it'll be called hydronium ion, H3O+. And so here we have a non-metal oxide, carbon, which is a non-metal, and oxygen. And so you can see it produces H2CO3, and so there's your hydrogen. And then here we have a non-metal oxide, phosphorus, which is a non-metal and oxygen, and it produces H3PO4, which there is your hydrogen, indicating an acid. So hydroxide indicates base, and hydrogen ions indicate acids. So what's going on with those metalloids in the middle? Well, metalloids generally have some of the properties of metals and some of nonmetals. So for example, this is silicon. It's shiny like a metal, but if I hit this with a hammer, it's going to crack. It's brittle like a nonmetal. So it just has some of properties of both. So it says, which two of the following elements would you expect to show the greatest similarity in chemical and physical properties? Remember, elements in the same group or column tend to have the same physical properties. So if you look, we have B, Ca, F, He, Mg, and P. And so if I look at the periodic table, I can see that Ca and Mg are in the same group. So those would have the same chemical and physical properties because they're in the same group. None of the rest of the elements are in the same group. All right, and remember, a group is a column. So it would be Ca and Mg because they're in the same group. All right, so it says locate sodium and bromine on the periodic table, give the atomic number of each, and label each as a metal, metalloid, or nonmetal. Okay, so find sodium on the periodic table. It says, so here we'll start with sodium. It says give the atomic number. So sodium is number 11. And label each as a metal, metalloid, or nonmetal. Sodium is on the left of the periodic table, so it is a metal. Then it says bromine, Br. Bromine is number 35 on the periodic table, so atomic number is 35. And because it's on the right, it is a nonmetal. All right, so hopefully you got that one right. This first section is pretty straightforward and easy. So really for chapter 6, 6.3 is the toughest. All right, so what property did Mendeleev use to organize? Here's the periodic table. He put it in order of increasing atomic mass. Increasing atomic mass. So number 2, how are elements arranged in the modern periodic table? It is by increasing atomic number. Increasing atomic number. Number 3, name the 3 broad classes of elements. That would be metals, nonmetals, and metalloids. Metals, nonmetals, and metalloids. Number 4, Which of these sets of elements have similar physical and chemical properties? So remember, when you're looking for similar properties, you want the same group or column. Okay, these are in the same period, so they would not have similar properties. These are in the same group, so they would. And then C, they just gave you a bunch of elements that start with N. That doesn't determine the properties at all. Okay, so it would be B because they're all in the same group on the periodic table. So like I said, similar properties are always in the same group. So it says identify each element as a metal, metalloid, or non-metal. All right, so really you just need to look at where they are on the periodic table. So gold is in the middle, it's a metal. Silicon touches the stair-step line, so it's a metalloid. Sulfur is on the right of the periodic table, so it is a non-metal. And barium is on the left of the periodic table, so it's a metal. So really, the main thing you need to know is this right here. Where are they? So these are all my metals, except hydrogen is a non-metal. Everything that touches the stair-step except for aluminum, that's a metal. Those are all metalloids, everything that touches the stair-step, and then my non-metals are on the right of the periodic table and hydrogen. And then everything down here, your lanthanides and actinides, are also metals. All right, so as long as you know where all those are on the periodic table, then you should be able to answer that. All right, and the last one says name two elements that have properties similar to those of sodium. So remember, elements with the same properties are in the same group. Okay, so you have lots to pick from. So sodium is Na, it's in group 1. The one that's actually the least like all the rest is hydrogen, but you could say hydrogen. But you have lithium, potassium, rubidium, cesium, and francium to pick from. Okay, so just pick whichever two you like the best. All right, so that is the basic setup of the periodic table, and as you go through the other lesson videos, you'll just learn more and more. Like I said, please pick up everything you can. The more you know about the periodic table, the easier everything else is for the rest of the year.